Okay, so now let's move to the second part of the demo. This is the new art exporter version 2.0. And now first, let's go to model real-time and take one of the models. So this is a simple model. It is defining capsules. There is a top capsule, and there are two more capsules communicating with each other. There is a protocol, and it has one event called move. And this event is using point data class. So we are passing this data typed by this point class. We are passing in the move event between these two capsules. The transitions are quite simple. So here in capsule 2, if we can see in the state machine, we are receiving a move event in this state 1, and we are just printing the data that we have got in this with this event. And capsule 1, it is sending this data. Here in the initial transition, we are defining a variable point, and we are passing this point in the data, in the event, in the move event. This point, this is a class, and it has two internal private fields, and also a number of getters and setters for each field. So if we run this model with model real-time, we can see how it behaves and what it prints. So this is the target code generated. So we can see that now this point, the header file and CPP file for the data type point, it is also generated, and it includes the type descriptor inside. So it has the data type, and also the type descriptor is generated, and then the CPP file as well. And this is the printout that we got from the application. So now let's try to export this complete model to code real-time. And currently, it's only until the June release, it's only possible to do this from the command line with the model compiler. So there is a zip file that we are delivering, and it looks like this. I have already downloaded it. It's called backend and version, and then timestamp.zip. So, and the model compiler executable is inside the zip file. So first I am unzipping it to some folder. Then under the plugins, there is this jar file, this plugin in the jar, and I also need to unzip it. And inside this jar, I can find the tools folder with the model compiler. So this is a Java executable, and here we have libraries that are used by this Java executable. And the command line that we need to use must define the following settings. So this is RCRTE home. This is a property that should be passed to Java itself, to JVM. And this is a path to the existing model real-time installation RCR_RT folder, which contains target RTS runtime library. Below are the command line arguments that must be passed to model compiler. Root folder, minus root, that's a folder where we have our workspace. So here we can see that the whole workspace that contains our project coordinates. This path must be passed to as this root argument. Then out, this is the folder where we want to get the result and exported art model. Then the command line option -- export art. That means that we want to export art. And the entry point is the TCGS that we want to export. And now this is the complete command combined in one line. So I will use default TCGS. Here it is. This is the TCGS responsible for the complete application. This is an executable TCGS, and it includes everything that is in the model, just the top folder. So I will use this from the command line. So now it's done, and I see that we have two files generated, and these two files are the C++ files, and also we have generated 4 art files. So in the art exporter, for data types like this point, we are generating pure C++ header and CPP file. For all other entities like protocols and capsules, we are generating art files. So here we have generated 1, 2, 3, 4 art files for capsules, 3 capsules and 1 protocol, and 2 C++ files for the data type point. So let's see on disk how it looks like. This is the folder art with the generated files, and the name of the folder is the same as the name of the project, and here we can see these files. So now in order to use them, we need to import them to our code real-time workspace. So I will use this command, add folder to workspace, and now I need to find the location. It was art exporter, art folder, and these coordinates. So I'm adding these coordinates, and we can see now what was exported. So there is a capsule with the code snippets, another capsule. Then for the data type, it was the data types, they are exported to C++ header and CPP files. And now the header and CPP file, they become source files in the exported model. In model real-time, we had this data type as a UML class, and the header and CPP files, they were generated. Now the header and CPP files with the data type definitions, they become source files. But still, we will be generating type descriptors automatically. And that's why we have this RT auto descriptor attributes specified for this point class. In the CPP, we can see that we have exported all the necessary operations for this data type, and also getters and setters that were defined by the user. They are also exported. So for the top capsule, there is one small manual thing that I have to do. I have to remove this duplicate export for capsules, but this is a known issue, and it is already fixed in the latest version of Art Exporter. So now I'm ready to try to build this model from code RealTime. We also can notice that the TCGS file is also exported. It's a very short and simple version of the TCGS file, but at least it contains the top capsule and the name of the target project. And in simple cases, it's enough to build an application. So let's try to build and see what will happen. So it's building fine. During build process, we are generating a make file, and the make file, it will be also building this CPP and header file from the project as the source files. And additionally, it will be building the generated type descriptor for these data types. So here we can see that the type descriptors were generated automatically, the header file and CPP file, and they are automatically included into the build. Now the build is fine, and we can try to run generated application. I can as well call run on this TCGS file. So now the generated application is started, and we see that there is the same printout that comes from code RealTime now. So here in capsule.art, we are including, we are generating additional include files, and this is also done automatically by the art exporter, but there must be a dependency in the original model RealTime model. So here in capsule 1, for example, we have under the dependencies, we have a dependency to this point class. And it says that in implementation, there must be an inclusion, and this dependency results into this into generation of this include directive, and it's a pure C++ code which is included as a code snippet to the art file. And you also can notice that since this point .h, it has an automatically generated type descriptor, then the include looks like this, RT type underscore point. So we are including it, we are including a type descriptor header file, but the type descriptor header file itself, it has also an include to the original point.h file, which comes from the source project coordinates. So here we have checked the scenario where we export a complete model, but in some cases we want to export some parts of the model. And for example, if we want to export only this the data type point, then what we must do is to define a separate TCGS file. This is a complete copy of this default TC, but the only difference is that in the sources list here, I'm using only the data type that I want to export. So here I have specified point data type, and also I changed the artifact type to become a library because now I don't have a top capsule in the sources, but only data types. And now we can see what will happen if I will just export this data types. So I'm also now using a command line, and here the command is absolutely the same, but just I provide a different name of the TCGS file, of the top TCGS file. So now I will run this export. Yes, and we can observe here, let's go directly to this code real-time. I already have imported, I think, yes, this coordinates data type. It comes, if you see in this path, it comes from that art folder, which I have provided as an output folder for my art, for exporting art. And we can see that now we have only this point exported, header and CPP files, and data types.tcgs. I have actually renamed this project to have this underscore data types at the end, because I want to now try to use these data types in my model real-time project. And since my original project was called coordinates, I had to add this postfix data types to make the name of the project different. And also here I have updated the name of the target project also to use this underscore data types additional name. So in here, if I build this from code real-time, I will get a library. Since now this is exported as a library. Now build is completed, and it is possible to use these data types now in the model real-time project. So what we have to do is we have to have file, then import, and then import projects from folder or archive. And then I select a directory and I point to that the location. This is my coordinates underscore data types project. I will not select it now because I already have it. I already have it imported. So here it is. And below you can see the path that it comes from this art coordinates data types. And now I can see that all the content, the same content I can see in my model real time. And now I will try to use this. For that purpose, I have created a separate project. It's called Coordinates 2. And it's similar. This is a similar project to my original one, but I have removed the point data type. I have removed it. Now it's not available here. And I have specified data types, TCGS, as a prerequisite to my default TC. And now I have an opportunity to use these data types from this library. So if I build this project, as a first step, I will get an art compiler. This art compiler is called on the TCGS file, which comes from art. And this TCGS, it contains data types that we have just exported. And after the art compiler, there is also a model compiler call, but I guess now it is, it was not invoked since I have already executed the build step. So I have tried to use this data type in my code snippets here. For example, in the initial state, I am using this point, and this point now, it comes from art. Also, I had to manually here add and include point.h. So the compiler will see this header file, but this header file now it comes from my art project. I tried also to, if we run this application, in the initial step, I'm just printing this point in the initial transition. Unfortunately, now it's not yet possible to use it in the protocols as the data because the code generator, it doesn't know this data type. So I think we need to do some more additional handling in the art integration to support data types that come from header and C++ files. But if we don't want to pass this data, but if we just want to use the data types in some C++ statements, then this is already possible. So I will just try to run this, and I guess we will get the printout on the screen from this point. So there is some delay. I don't understand why. Oh, yeah, now it started. So here I have this coordinates to target generated. I can see that I have an art MK file, which is responsible for running art compiler and in adding the generated files and files from art project to this build process. And now I see that I got this printout. Of course, I was not yet sending this point through the protocol, but I was using it directly in my initial transition. That's all. Do you have any questions?